The purpose of this short video is to explain a fundamental idea about Bayesian statistics. And that's the idea that it operates by starting off with some prior belief about a parameter or parameters, collecting some data, and then on the basis of that data, adjusting, modifying that prior belief to arrive at a posterior belief. And that's what this figure down here in your notes is meant to show. So this panel A is extremely important because this is the basic typical expression of Bayesian statistics. And in Bayesian statistics, we're typically going to be focused on theta, which is the parameter of interest. And this expression here represents our prior belief about theta. And what we've got right here is our posterior belief about theta conditioned upon the data that we actually observed. So we're going to start off with a prior belief. We're going to wind up with a posterior belief, and we're going to get that by multiplying by this component here. And so this component here, I've just isolated. So there's our prior, there's our posterior, and this is going to be how we adjust the prior, how we update the prior to arrive at the posterior. And to get a sense of that, let's just look at two of our three horsemen, war and famine, both of which initially would have prior belief of being 0.333, that they were the culprit. So let's start first with war. So let's think about war. So we start off with 0.333. And then we multiply it by this thing here. So what's this thing here? The denominator is 0.1148. So that's the probability of the data. That's the probability of getting 4 dead, and that is about 11.5%. And what we have in the numerator, is the probability of the data given a particular value of theta. And we see that up here. The probability of getting 4 dead, if the person responsible was war, with a theta value of 0.8, well, that probability is 0.006. So that's where this 0.006 comes in, 0.6%. Now let's think about it. The probability overall of getting 4 dead is about 11.5%. If war was responsible, the probability of getting 4 dead would only be 0.6%. So given that we found 4 dead, and the probability of getting 4 dead, if war was responsible, was this, the overall was this, we think that that data of 4 dead provides evidence that in fact war was not responsible, and therefore the posterior is reduced by this fraction. And the opposite is going to happen in the case of famine. So this 11.5%, that's just the probability of 4 dying. However, if famine had been responsible, there's a 25% probability of 4 dying. So if the probability of 4 dying, if famine is responsible, is 25%, the overall probability of 4 dying is only 11%. When we in fact observe that 4 are dead, that serves as evidence that, hey, maybe famine was responsible. So starting off with a prior, we now wind up with a posterior, which is very much larger.